Hi, it's Professor Murray. Welcome to Lesson 7 in Project Management. Lesson 7 is actually a two-part lesson. I'm going to talk about schedule. We're going to do it by hand a little bit. And then in part 2, we're going to talk about software and how the software will do a lot of things for us. First thing, there's a lot to read in the PMBOK, in the textbook for project management. I think this chapter is somewhere around 60 or 80 pages. There's a lot in it, so again, you have to do document skimming. I don't want you reading the whole thing, but you need to have a look at the different parts in that chapter. The chapter in the book, it's in part 1 and it's chapter 6. There's 6 sections to this chapter. You kind of need to go through all of them, but mostly you want to focus on the center 4, 6.2, 3, 4, and 5. The 6.1 and 6.6 they're relevant, but they're not too much in there that you have to worry about. In 6.1, it talks about schedule management, or planning how you're going to manage your schedule. You're going to come across a lot of different terms in project management, such as PERT, CPM, Gantt, critical path, agile project management, lean project management, and a couple other terms, AON and AOA. Now, here's the deal. These terms, we're not going to go in depth. You need to know what these terms are. Pause the video right now or do it later, but you need to Google each one of these terms, figure out what it means, and just kind of know what, not the details behind it, but you have to know, for example, what PERT means, because someone might ask you about that on a quiz or a test. The main ones that we're going to deal with are CPM and Gantt. In section 6.2 in the text, it talks about defining activities. And another word for that, or another phrase for that, is the work breakdown structure. This is the foundation of project management. You need to become very familiar with work breakdown structure. And here's what one looks like over on the left side. I've got a work breakdown structure for installing a milling machine. I have a bunch of tasks listed, and then over here I have the duration, how many days each task will take. And these are all estimates. So we have to purchase the mill. We need to do things like get our quotes, place an order. Eventually we have to pay the invoices. There's a delivery category. Now these are purchase, mill, delivery, installation. Those are main tasks. And quote, place order, pay invoices, those are subtasks. Sometimes we have 2 levels, sometimes down here we have 3 levels, and you might even have more levels. This is a very simplified version of a work breakdown structure. I have maybe 20 or 30 items here, and there's no way I've covered every item that needs to be done for installing this mill or purchasing and installing it. A typical project would have hundreds of tasks. So you have to be quite detailed when you make your work breakdown structure. So this is kind of what they look like. You've got a list of tasks, and they're grouped into similar categories. And then you've got the duration for each task, how long you think each one is going to take. And that's the first step in 6.2, defining the activities. Next is we have to sequence the activities. And that's deciding which activities are related to which other ones and how they're related. Does one start after another one finishes, or do they both have to finish at the same time, or maybe they both start at the same time? We also have to eventually find a critical path. We have to figure out what that is and why it's important. Here's an example. The ones that are being circled, these are part of a sequence. Here we've got place order, ship, move to site, electrical connections, plumbing, and test operations. You notice that this sequence are all pieces of different task categories. A category is related topics, and then a sequence are things that happen before and after each other. So they're kind of similar, but kind of different. Now, if we look a little more detailed at this, you'll see the ones that are in red, that's a critical path. And this one here, plumbing, is not part of the critical path. That's because electrical and plumbing are done concurrently, and we can see that electrical connections, that's 5 days, and 2 and 1 for some other electrical things. So we have 8 days of activities here. In plumbing, we only have 3 days of activity. Even though these are sequenced together, plumbing and electrical are perhaps start at the same time, so start to start relationship. But plumbing could actually be delayed a couple days and it wouldn't change the outcome of the project. If electrical was delayed a couple days, then it would delay the overall schedule of the project. These items are on the critical path, the ones in red, and we'll talk about that more soon. Here's another example. This is an automated warehouse, and the first step is to define the relationships. So here we've got a network diagram that shows some sequence relationships, and there's only 8 activities in this project. The first step is to map them all out and say which ones relate start to finish to each other. And this is a bit different view, but it's the same activities. And here we've put it into a little table for each one. The little table for each activity, there's a legend down here in the corner. These stand for earliest start, earliest finish. ID is just identification, like here we use A, B, C, D. So we've got the ID, the description in the center. Now on the bottom we've got late start, late finish, duration, and the slack time. Okay, let's take a look at what we've put in here. We've got our 8 tasks, we've got their ID letters, and we've got the duration for each task. So 10 days, 25 days, 50 days, 15 days, and so on. That's the first step, or second step, in laying out the network diagram. First we just do the relationships, then we add in the durations. Now we're going to do what's called a forward pass. Task A starts on day 0, and it takes 10 days. So the earliest that that task can finish is on day 10. And then we go to the next 2 tasks. Their earliest start is day 10 because they can't start until this one finishes. So they both get an early start of 10. Design hardware takes 25 days, so the earliest it can finish is day 35. This one takes 5 days, so it can finish by day 15. And we progress from left to right through the matrix, calculating the earliest start and the earliest finish based on their durations. Down here near the end, we've got 3 coming in together. So on test software, the earliest finish is day 70. Build and test hardware, earliest finish is on day 85. And this one, the earliest is day 50. We have to take the largest number, and that's the earliest that this last task can start, because it has to wait until all 3 of these are finished. So it gets an early start of day 85, takes 15 days, and the earliest finish is day 100. That's the forward pass. Now we have to do a backward pass. And what we're going to do here is, notice we have earliest finish of day 100, so we get latest finish also of day 100. Now we work backwards. Take off the 15-day duration. The latest finish, the latest start for this guy is day 85. And we work backwards through all of them. So late finish is day 85 minus 35-day dilation. Latest start is day 50. And we just work all the way back through them. You notice here we've got 2 connectors. So this one, latest start is day 70. This one, day 35. So now we have to take the smallest number. and that gets the latest finish at day 35 here. That's the backward pass. Now we have to complete this by calculating the slack time for each activity. And the slack time is just the latest start minus the earliest start. So this is both day 85 and we've got 0 slack. Here we've got latest start of day 50, earliest start of day 15, and we've got 15 days of slack. That means this task could move either direction by 15 days and not affect the outcome of the project. If you look at these guys down the center, and they just happen to be in the center, there's no significance to position, none of these have any slack time. That means these are all on the critical path. Any change in them will change the overall outcome of the project. In these ones that aren't on the critical path, there's a little bit of flexibility. They could be delayed a little bit and the project wouldn't be affected. There's an exercise for you to do on doing critical path management, CPM. I've included a template in PowerPoint that you might want to use. So let me show you how to use that. Each one of these is a little table, and you can click on it and then go Control D for duplicate, and that'll make a duplicate copy, and then you can move that around. So let's start with this. I'm going to duplicate it and move it over here. And here's my legend down here. I'll keep this one unaltered. So here I'll put task A, and this might be maybe foundation. And the duration, I'm going to put 5 days. Earliest start for this task, since it's at the beginning, would be at 0. That's all I start out with. I want to connect that with something, so I'm just going to go up here and grab my line tool, and I'm going to draw a line. I want to make one of these for each one of the tasks. I just did Control D to make all those duplicates. And I'm going to arrange them wherever I want. And I'm going to draw some connector lines to connect them all. Notice when I draw my line, it automatically gives these landing spots. So it's kind of smart and intuitive the way it helps you out. Okay, so there I've started my network diagram, and I can put in all my descriptions, I can put in my durations, then I do my forward pass, and then I do my backward pass and calculate the slack. Talk to you soon. Bye.